Good morning, afternoon, or evening, everybody. This is Brin with Train by Tex. It's been far too long since we've been together. We have a car, and we'd like to share it with you. So, specifically, a 2005 Chrysler Sebring convertible 2.7 liter. It's gray, just in case you're wondering what color it is. This vehicle was brought to us by another shop. Symptoms are that it runs rough, and there's a check engine light illuminated for some fault codes. The fault codes there's 4 of them actually. One fault code for each oxygen sensor, and they're heater related, O2 sensor heater related fault codes. So yeah, that's the symptoms. The shop it replaced a couple of the oxygen sensors, and they have their suspicions of what's going on, but they were having a hard time proving what they were suspecting, and that's where we come in. They asked us to see if we couldn't help them confidently get this thing diagnosed for their client, and of course we are more than happy to do so. So come along with us and see if we can make sense out of this thing, see if we can learn some stuff together. All right? Okay, so here's our car, or one that looks very much like it. 2005 Sebring convertible 2.7 liter, gray in color for those of you that care. And our concern again is rough running, or intermittently rough running, although it's fairly duplicatable, if that is a word, with some check engine light illuminated and some O2 sensor heater faults retrieved from the PCM. I think it's important to mention that we shouldn't be assuming that the check engine light in the fault codes that are retrieved from the PCM are related to the rough running condition. And one way we can get a better feel for whether they are related is asking our customers or our clients if the check engine light illuminated about the same time that the rough running condition took place, and that would at least make it seem like they're probably related. Now, if the check engine light's been on for a long time and now all of a sudden is running rough, then we'll know that whatever codes we pull from the PCM may or may not be relevant to the rough running condition. So we did pull codes on this vehicle, and these were the codes that we pulled: the PO 135, 141, 155, and 161. If you'll see the description, you see sensor heater performance. I'd say it's safe to say most of the time when we pull heater codes, usually it's the description suggests that it's a circuit code, or it will say circuit literally in the fault code description. As you can see here, it says heater performance, and I think that we generally all look at the description and start to make at least some assumptions of what's going on. And when it comes to fault codes, we're usually looking for descriptions to either give us an indication whether that's a performance issue or a circuit issue. And in this case, we can see again that it says heater performance. Now, if we read this, it says when monitored, engine running, and heater duty cycle greater than 0%. The set condition is O2 heater temperature does not reach 959 degrees within 45 seconds for bank 1 sensor 1. Bank 1 sensor 2 is the same. Bank 2 upstream is 959 degrees Fahrenheit within 90 seconds, and then bank 2 downstream is 662 degrees Fahrenheit within 90 seconds. Now, not that we need that information per se to help us make a diagnostic decision, but the time window can certainly help us. But that said, I just think it was interesting that the bank 2 system is giving more time, and that the temperature is different for the downstream sensor. But as you can see, the description says performance, and you can see in the set condition it makes sense. I don't know about you, but I've never been aware of a situation where an oxygen sensor has an actual temperature sensor built into it. So how does it know whether it reached 959 degrees Fahrenheit? Well, it's pretty simple. for most cars anyways, you have a 0 to 1 volt switching, a conventional style narrowband oxygen sensor. That's what happens when it gets up to operating temperature. It switches, and it switches below 200 millivolts and above 800 millivolts, and it does so at the proper frequency depending on the load. In this case, it goes a little more complicated. Chrysler in this generation, the O2 sensor signal, if you were to look at it with a scan tool, it starts out at like they put a 5 volt bias on it, I guess is lack of a better word. And that 5 volt bias, as the O2 sensor heats up, that 5 volt bias is reduced to a 2.5 volt bias. It's still a 0 to 1 volt narrowband switching conventional sensor, but it rides on the 2.5 volt bias. So instead of being 0 to 1 volt switching, it's 2.5 volt to 3.5 volt switching. But I just want to make it clear that when you look at scan data, initially the O2 sensor signal will be about 5 volts, and as the O2 sensor comes up to operating temperature, you're going to see it switching. You drop down to that range, the 2.5 to 3.5 volt range, and of course you're going to see it switching at the appropriate frequency for the load that the vehicle's being operated in. This system monitors that signal, which again starts at 5 volts and then it drops back down to 2.5 to 3.5 volts. It monitors that, and it can tell by watching that signal if the O2 sensor has gotten, in this case you'll see bank 1 upstream, 959 degrees Fahrenheit, and it has to do it within 45 seconds or this fault code sets, and similar for the other fault codes here displayed. If you look below, you have possible causes. You have an O2 sensor heater operation, O2 sensor heater element, O2 sensor ground circuit is open, O2 sensor control circuit is open, or the PCM. These three right here are a pretty good hint as to how the circuit operates. Generally with an O2 heater, you're just going to have 2 wires that run the heater of the oxygen sensor. You're going to have a power and you're going to have a ground. Well, they're not always on, or I shouldn't say that. Well, that's a true statement. They're not always on or on 100% of the time. Usually when you first start at cold, you will see that they are 100%, or at least in scan data suggests that it's 100% duty cycle, and I think if you were to scope it, you'd also see that. But in this case, because we're differentiating the ground circuit being open or the control circuit being open, we can almost assume at this point that their O2 sensors are probably sharing a ground, because they only need one part of that circuit to be isolated from the other O2 sensors, because not all 4 O2 sensors are going to need the same heater control. So I think it's safe to assume that the control side is going to be the power feed from the PCM. The other thing as diagnostic technicians we have to do, we talked about if the fault codes or the check engine light illuminated about the same time that the engine started running rough, we can almost assume that they're probably related. And in this case, we can see, we all know that we need functional oxygen sensors for the air fuel management to work properly, and if the PCM's not able to manage fuel, then the vehicle is going to run rough, especially if it's in a lean state. So at this point, we are thinking that they're likely related, but let's look at some scan data. Let's start this vehicle cold. Let's look at some scan data and see if we can get any more information.
Okay, you can see the engine's running pretty smooth, and our closed loop timer there just got to 0. And let's see here, our loop status in this case, sorry about the glare, is still open loop. You see how bank 1 went closed loop. You can see the engine is now, or you can hear it anyways, is barely running. Again, I went back into open loop and back into closed loop. For some reason only on bank 1. Bank 2 is staying open. When we looked at the O2 sensors here, bank 2 both upstream O2 sensors seem pretty lazy, so I'm not sure why it's only going into closed loop. Well, look, now they're both trying to go to closed loop. Yeah, they're staying in closed loop now, but it's running like crap. Anyways, there, open loop. You hear it surge, and it kind of runs better for a second when it goes into open loop.
As we were saying, you could see that from the video that every time it was going into closed loop, the vehicle was running rough. Every time it went into open loop, it ran way better. You could hear it kind of the engine kind of surge in the transition between open and closed loop. But basically, when the PCM attempted to go into closed loop, at that point it's of course looking at the oxygen sensors to determine if it sprayed the correct amount of fuel in. If it gets indication from the oxygen sensors that it didn't spray the correct amount of fuel in, it's going to try to make adjustments to make sure that the air-fuel ratio is correct. That's fuel management. Of course, fuel trims come in is when it sees that the oxygen sensors indicate that the calculation wasn't correct, indicating a rich or lean condition. Then it's going to make some adjustments to either add or remove some of the fuel from the fuel base pulse width calculation. So it's going to take some fuel away or add some fuel, and it's going to show that, or that's going to be represented in short and long-term fuel trim. In this case, this brief capture here was closed loop on both banks. Bank 2, you have 49.1, negative 49.1% between the two, total fuel trim bank 2. If you look at bank 1, you have negative 36.3, I believe, fuel trim, total fuel trim on bank 1. What's interesting here is that this engine was started fairly cold, and you could see it trying to bounce back and forth between open and closed loop. Certainly we would think that the heaters would be commanded on, and you can see here that we have 0% heater duty cycle here. So why is the PCM not turning the heaters on? That's just something to think about as we move forward. But real quick, I want to touch on what we think is happening here, and a couple things here. When you're talking about narrowband conventional oxygen sensors, we've talked about, certainly most of us have experienced heater circuit fault codes, and when we do, we rarely have any obvious drivability concerns. Certainly we can have drivability concerns, but it's really not that common, at least in my experience. Being in a state that doesn't do emissions testing, some of our clients that aren't really the concerned type, I guess is the best way of saying it, if their check engine light is illuminated and they have no symptoms, they're less concerned about dealing with the check engine light. And oftentimes it's not uncommon, I should say, to have that scenario come up and it be a O2 sensor heater circuit fault. But so why is it that happens, but then we see in this case we certainly do have drivability concerns, and we suspect it's because of the O2 sensor heaters not functioning. In this case you can see there's 0%, and our O2 sensors aren't where they need to be. If you look at bank 1 sensor 1, we're at 3.29 volts. I told you this is a 2.5 to 3.5 volt range. Now this is just a brief, one single screen. We don't have it graphed out, and I apologize for that. But if you look, 3.29, if it's 2.5 to 3.5 volt, the 3.29 indicates a rich condition. That's about 800 millivolts if you're thinking in terms of the 0 to 1 volt switching oxygen sensor. If you look at bank 2, you have 3.93 volts. Well, if it's 2.5 to 3.5 volt range, normal operating range, this isn't even normal operating range. This is certainly above what would be even 1 volt in a conventional 0 to 1 volt switching system. This would be 1.4 volts. So even though it's outside of the normal operating conditions, the PCM still thinks of that as a rich condition, which I think is odd that it would even trust this oxygen sensor if it's not even in the 2.5 to 3.5 volt range. But again, part of that is just, every car is a little different with strategy, and obviously in this case the strategy is kind of dumb. But so regardless, once the PCM, I remember telling you that the signals start off at 5 volts, and as the O2 sensors get up to operating temperature, they should be between 2.5 and 3.5 volts. Well, the PCM looks at closed loop timer, but it also pays more attention to the oxygen sensor. The closed loop timer is just kind of calculation. It should be ready to go in closed loop by this point, by the time it reaches 0. But it's really paying attention to the oxygen sensors. If the well, I should say, I suspect it is. It would only make sense. But if the oxygen sensors aren't even in the operating range, like we see here in bank 2, 3.93, that's not in the operating range. If it's not in the operating range, why is it trusting it and trying to even go in a closed loop? That's kind of another kind of dumb strategy type of situation. But it's something we deal with, and just keep in mind that this isn't necessarily going to happen on every Chrysler model year you work on, but it's happening here. So if these are indicating rich and the PCM is trying to trust the oxygen sensor, then it's going to try to take fuel away. And we see evidence of that with negative 36.3 on bank 1 and negative 49.1 on bank 2. So that's what's happening. Our O2 sensors are not even being turned on for some reason, and if the O2 sensor heaters, I should say, not being turned on, if they're not being turned on, they're not going to be functioning very well. And I think the difference is, why does this happen here and doesn't happen other times? I think it's because of this generation Chrysler. Because they put a 5-volt bias on the O2 sensor signal, and it has to wait for that bias to get reduced into the operating range of 2.5 to 3.5 volts. Where a conventional system that uses a different strategy, that they don't put that 5-volt bias on, if the O2 sensor heaters aren't working, or if their O2 sensors aren't getting hot enough, or if they're lazy, they're just going to stay near 0 or dang near lean, which if the oxygen PCM were to trust a sensor that didn't have this strategy, let's say we're talking about a vehicle that stays lean, if the O2 sensors heaters or O2 sensors aren't getting the operating temperature, or if they're just lazy, you're less likely to have drivability concerns under those circumstances, because the PCM would trust that the oxygen sensors are at least trustworthy enough to be in closed loop. It's just going to add some fuel to it. So that would basically take the engine, and instead of being at stoichiometric ratio, it would be rich from stoichiometric ratio, because it would be assuming it's lean when it's really not, and adding more fuel. In this case, because we're starting at 5 volts and we have to drop down to the 2.5, 3.5 volt range, and we're really above the, at least on one bank high, indicating rich, and the other bank really outside of the operating range, but still PCM considers it rich. This engine is probably running close to stoichiometric ratio, but the PCM is making an assumption that it's rich, so it's taking away fuel, and you're going to get more drivability symptoms on vehicles that are running lean than you will if they're running a little bit rich. So this is the scan data. We're very confident at this point that this is what's going on. The vehicle is running rough, and it has everything to do with the O2 sensor heaters. What we're going to do next is actually look at the diagram, because we want to scope the sensors, and we're going to start with bank 2 upstream. Before we scope them, we did say that the shop replaced the oxygen sensors, or at least a couple of them, and we don't know what sensors they put in, or if they're compatible or not. It's not likely that they're all 4 been replaced with this incompatible sensors, but we have, stranger things have happened. Because bank 2 upstream is so easy to get to, we're just going to check the heater resistance in this 102 sensor real quick, because it's super quick test. We can simply unplug it. It's right out there in the front by the radiator, and put our meter in. Make sure we look at service information. We can see from service information it's got to be at operating temperature, which the car was, and we're going to measure that heater resistance. You can see upstream sensors here, bank 1 sensor 1 and bank 2 sensor 1. The resistance needs to be 3 to 4 ohms. We can see here it's 3.9 ohms. Again, I know this isn't a comprehensive test. It's just something we could do real quick. We did so. Going back to this, getting ready to scope these heater circuits, we're going to put one test lead here at 2. At this pin 2 of the O2 sensor connector, and what we expect to see is a square wave, or a duty cycle control from the PCM when the PCM is trying to turn the heater on. We're going to put another test lead here near pin 1 at this O2 sensor connector, and we're expecting to see a stable ground here. And we're also going to add a current clamp here to see if we have actual current flowing, because we can have a duty cycle control here, but if the circuit's open or if the circuit's shorted, we wouldn't necessarily know what the current is doing in the circuit. If it's open, we wouldn't have current flow at all. If it's shorted, then we're going to have excessive current. So that's what our test connections are going to be like. Here's our connection at the oxygen sensor. We got our scope ready and started the vehicle cold, and we expected to see command from the PCM, and we didn't. And we expect to see some current flow, and we didn't. So what we did next is we moved the test leads over to the PCM. If you look here, if our test lead is here and we're not getting a command from the PCM, if we were to move our test lead closer to the PCM or right at the PCM, if there was an open circuit, then we should see a command here, but we wouldn't see it here. And that's what we're trying to do. We're just trying to, it's best to always start where the circuit terminates if it's feasible, if it's easily accessible, and that's what we did in our case. But being we're not getting a signal here, we're going to go ahead and go here. We moved our test leads, and we still didn't get a trace. So what we decided to do next is actually bidirectionally control the O2 sensor heater while scoping it. And you're seeing a DRB3 here, which is a factory scan tool for Chryslers, for non-CAN Chryslers. We're fortunate to have the scan tool, but I will admit that I don't always, even the vehicles that I have factory scan tools, I don't always just grab the factory scan tool. I usually grab my Snap-on just because I like using it. I like the way it graphs data. I like the way it saves files, screenshots, all of that stuff. I just like using it. So when we started, we used the Snap-on to try to bidirectionally control the O2 sensor heaters while we're scoping it. And when we did, there was nothing happen. Again, we saw no signal from the PCM trying to command these O2 sensor heaters. So we were starting to think, well, maybe there's something going on here. Maybe this is a clue. But what we did is we decided to go ahead and get their DRB3 on the vehicle and try it again. When we got the DRB3 on, by the way, when we were trying to do the bidirectional control with a Snap-on, the engine was running. But when we got the DRB3 on, we saw when we tried to do the same thing, there was an error. It said that this was a key on engine off test only. So the difference between aftermarket and factory scan tool in this case is the Snap-on did not give us a warning or an error that this was a key on engine off test, where the factory scan tool did. Again, holes. It's just something to consider. So we bidirectionally controlled the O2 sensor heaters key on engine off, and when we did, this is what we got. We're not showing the ground here. Hopefully you'll take our word for it. The ground was good. The blue trace is the O2 sensor high side control from the PCM, and the current, the green trace is the current flowing in the circuit, O2 sensor heater circuit. So you can see every time the PCM turns the heaters on, current flows. In this case, because it's duty cycle, you can see it's on probably about 2.5 times or 2 to 2.5 times as long as it's off, which is roughly 60 to 75% duty cycle. But we don't necessarily know if this is perfect, but I will tell you that I did a little bit of research, and this is right about where we need to be. I weren't sure if the current was too high or too low, but again, we did some research. Everything looked like this was just about right. This looked good. And again, we're looking for more of a gross failure, and this certainly isn't a gross failure. Here's where we made a mistake earlier when we were trying to start the engine cold and trying to watch this, monitor this signal using our scope, the heater circuit using our scope. We made the assumption that the heaters were being turned on. But if you remember from this capture earlier, we could see that the heaters weren't being turned on. So our mistake really was we should have been monitoring the scan data while we were starting the vehicle and monitoring the O2 sensor heater circuits. Instead of assuming that it was going to turn the heaters on, which we already saw that it didn't before, that's where we made our mistake. When we weren't getting a trace, it was because the heaters weren't on. We did, in fact, get a very similar trace to this one at one point when the PCM commanded the O2 sensors heaters on its own without being commanded to bidirectionally with a scan tool, and we saw the same trace. So if we go back to the fault code description, this is monitored with the engine running and the heater duty cycle greater than 0%. After retrieving the fault codes and documenting freeze frame data and anything that we need to document, we cleared the fault codes out. And after clearing the fault codes out and starting the vehicle, we had our scope attached to the heater circuit, monitoring it, and we never saw evidence that the PCM was even trying to turn the O2 sensor heaters on. So the takeaway here is it monitors it when the engine running and the duty cycle for the heaters are greater than 0, and if O2 sensor signal doesn't show activity within 45 seconds, then it's going to code for this fault. That's what the service information says. But what we found when we saw no heaters being commanded on, we backed back out and assumed that that was some kind of fault strategy and that there would be a fault code in the PCM, and there wasn't. And that was in the evening, by the way. We tried it several times. There was no fault codes. We just monitored the O2 sensor heaters, the scan tool, and we showed 0%. Of course, we weren't getting a signal with the scope on the O2 sensor heater circuit. We'd go back in and check for fault codes, and there would be none there. And a takeaway here is that this happens. You know, sometimes you'll see evidence of a fault strategy, but you won't necessarily have a fault code that helps you to confidently be sure that that's the case. The next morning, by the way, we did the same thing, but the next morning we did have fault codes showing up every time the heaters weren't even being commanded on. Again, PCM saw something it didn't like with the O2 sensor heaters, and it wouldn't even command them on. That's a fault strategy. But in the evening, the day prior, we didn't see any evidence of concluding that it's a fault strategy with a fault code. But the next morning when we came in, it did in fact code right away when the O2 sensors heaters weren't turned on. The other takeaway again is that the service information monitor and set criteria is not always 100%. There seems to be variables from time to time, and that's what we were dealing with in our case. So we're confident that the drivability concerns at this point are related to the O2 sensor heater performance faults, and we can see it's clear that the PCM sees a problem with the O2 sensor heaters, but when we actually scope the O2 sensors heaters when they're functioning, we see no evidence of a problem. And we had our scope monitoring the O2 sensor heaters when the fault occurred, and we saw no problems. So after some thought and some research, it became clear to us that this was in fact a PCM failure. Now, a lot of you out there have some experience with Chrysler, and you could probably argue that you could have guessed early on that it was a PCM that was causing this. But again, we don't operate based off of statistics. We test, and that's what we did here, and we were able to prove out that in fact the PCM was at fault. So we asked our client, the shop owner, to supply us with a PCM, and he did. We installed the PCM. We had a scan tool on the car ready when we started this vehicle for the first time after starting the PCM. What we saw is O2 sensor heaters were 100%, O2 sensor signal voltages were 5 volts, and rapidly that 5 volt signal voltage was reducing until all 4 O2 sensors were reading 2.5 to 3.5 volts, and switching, the upstream being switching and downstream being a little more stable. Of course, we saw the 100% duty cycle on the O2 sensor heaters drop down, and then this is after a few, I'd say a minute maybe, you can see 27% on bank 1 and about 35 to 44% on bank 2 heater duty cycle control. By the way, engine was going into closed loop very quickly and running perfectly fine, closed loop or open loop. And the next capture here, again, you'll have to take our word for us. We didn't graph the data, but with the DRB3, of course, we're not going to be able to. But this screen here shows our short-term and long-term fuel trims. A big rule of thumb for a lot of years, and this car certainly falls into that category. If you're close to 0, well, I should say every vehicle that I know of, if you're close to zero, you're doing well. Some modern vehicles fall out of the normal rules of thumb, so don't make assumptions that you know what's good and what's not good. But if our vehicle is running well, the O2 sensors voltages are where they need to be, short-term and long-term fuel trims are good, and our vehicle's not running poorly, it's safe to say that the vehicle's fixed.
Thank you so much for following along. We had a good time with this case study. We hope that you got something from it as well. If you have any questions or concerns, please don't hesitate to comment below. But more importantly, if you have any experiences or information that might be helpful to others and us, because we're all in this together, we learn from each other, please don't hesitate to comment. If you haven't already done so, please subscribe to our channel. We really appreciate the support. And again, we thank you for your time and attention. And we'll see you next time. Take care.